What matters is that you get the right amount of data to your users at the right time. My name's Colin Bowen. I'm a web guy from Canada. Thanks for having me all the way onto the other side of the world here. I hope to share with you a couple of great, interesting insights into both the underlying protocol behind SignalR, WebSockets, and why it's starting to change the landscape, but then show you how easy it is to get involved with the real-time web using this fantastic open source library. As we look at the scenarios for real-time communication, and when I say real-time, it's not necessarily always up to the second, but relatively real-time from a user experience perspective, there are quite a few of them. And some of them are the obvious ones, like chat. That's probably your canonical example, and that's actually what we'll be looking at just more as a basis for exploring the technology today. But there's some more interesting ones out there, like co-browsing. And just a quick little side story, a Canadian company that just got bought for a very handsome sum of money from the guys at Salesforce.com called GoInstance. They use this technology to change customer service. Instead of a customer calling up over the phone and trying to explain what they see on their screen, they leverage WebSockets to be able to browse with the client at the same time on the same web page. And it was a really interesting example of co-browsing and how it changed the customer service paradigm. There's also other types of real-time scenarios that are more kind of read-only or passive, if you will, watching your stock portfolio go up or down, watching your truck fleet as it progresses across a maps interface to see where your trucks are. We know that the web is getting away from this sense of just reading and writing documents and more about making more engaging and interacting experiences. As web developers, we've had a couple of tools in our toolkit for a while now to be able to create these kind of both collaborative and more observable type experiences. And largely, they've been consisted of hacks. And they're hacks to get over the concept of HTTP being a request-response protocol. In other words, how does the server initiate a conversation when it needs, by nature of the protocol, to wait for the client to request it? And so we've come up with some cute little things like hidden iframes that have long-running requests in it, polling type options where we constantly open and close and say, hey, is there any more data yet? No. Is there any more data yet? Is there any more data yet? And those have worked somewhat in terms of filling the gap. The challenge is that from a network overhead perspective, from an architectural perspective, they truly are hacks when you start to examine the technological cost of these. And of course, people have developed commercial solutions around trying to make that a little bit easier for you to make this happen. So, the summary is that you can do this today, but it gets even better tomorrow with standard APIs implemented consistently across all of the browsers. In HTML5, the collection of specifications, if you will, coming out, there's really two protocols being implemented to be able to allow you to do real-time communication. One is more push-oriented, and this is about the server kind of talking back to the client on a regular basis, or server-initiated or server-sent events. And then the other one, which we'll be digging into in a little more detail today, is WebSockets. And that one, by its very nature, has been architected for high-performance, bi-directional communication across a large number of clients. But of course, the challenge with any new spec is, when will it be supported? To understand why that question is so relevant, you need to kind of partly understand a little bit about how WebSockets actually works. In sockets, it's actually not HTTP that bridges that continues the conversation. HTTP mainly is the point that initiates the conversation. And then the protocol itself falls into a pure TCP conversation between browser and client. And so you'll initiate an HTTP GET. It will say, hey, I'm trying to open up a WebSockets conversation. The server needs to know about WebSockets because it needs to listen and respond accordingly to say, yep, you're good to go. Move over to this TCP port and continue talking. And then they keep talking on TCP. So in other words, to make this actually all happen, you have to have a browser that supports the spec. You need a server that can observe and respond to the spec, and they all have to agree on the right version of the spec, because as you can imagine, in any collaboratively developed protocol, trying to line up all the different vendors across the board has been a pretty big challenge. But have no fear, What I'll be able to show you today is how you can start using this for those that do agree and support some of the older clients that don't. And just to kind of give you a sense of that, where that support lies, we're getting pretty good traction in the latest rev of browsers. IE10, when the recently released Windows 8, has full support for the WebSocket spec that has been finally agreed upon. And as you can see, Firefox, Chrome, Safari, the rest of them, we're kind of finally there. So let's spend a few minutes taking a look at what it would mean to implement WebSockets today on iOS 8, on .NET 4.5, and with a browser. In this case, we'll use Chrome. And then what we'll do is we'll take a look at where some of the gaps are, and more importantly, where SignalR comes into play in the bigger picture. So I've got a simple chat application, just between, for example, as many, well, it can be as many people as you want, but this particular session is between 2 people having a quick chat about an upcoming product launch. And what we're going to do is actually develop the underlying bits, or put together the underlying bits between the client and the server side to show you a little bit about the protocol and give you some exposure to the joys and where some of the things could be a little bit easier from an implementation perspective. So let's go ahead and come to our client page here. So I've got a set of JavaScript here, kind of with some functions stubbed out. This is just a typical module pattern. And if you're not familiar actually with JavaScript and the module pattern, a quick plug, Friday, 9 a.m., we'll be doing a reintroduction of JavaScript for people who have cut and paste JavaScript in the past to teach you a little bit about the language semantics and help you close some gaps on that. So we've got a module pattern here that contains my communications mechanisms along with some jQuery that wires up the UI to that module pattern. jQuery is a little less relevant. What do I want to dig into is using the actual web socket protocol. So we'll start by opening a connection because any conversation is only as relevant as the connection itself being open. So let's go ahead and do that. So we'll start off with our connection variable and we'll say, I want to go ahead and create a new web socket. Now I'm going to stick it inside a jQuery. I'm going to wrap it with jQuery just so it makes it easier to wire up events. But the actual web socket piece is a native browser DOM class that can be used to connect to WebSockets. And so I'm going to say connect to the WebSocket on my current location. So I'll just leverage the current host. And then I will go ahead and tell it to access the chat handler on ASP.NET and pass in a query string, in this case, the name of the person that is connecting. All right, and what we'll do just for the sake of, oops, I forgot a bracket. And we'll go ahead and wire up some key events that happen in the WebSocket. So it throws off an error event when there's an error that occurs. It also throws off a close event when the connection is closed. And it throws off a message event when a message is received. And I'm going to put it into an event called received. And I'll just go ahead and get the first one, which is the only one I've created. Now, what's interesting about this is that as you look to develop both kind of server-side push and bidirectional protocols, as they've developed WebSockets, they've been syncing up the JavaScript API to the server-sent events. So if I was doing a server-sent event, the API outside the name WebSocket looks very, very familiar in terms of how it behaves. What you will notice here is a new scheme on the URL, WS:, this is WebSocket, and if you're doing SSL-wrapped WebSockets, it'd be WSS. In this case, we're just doing WS. So now that I've got a connection made, I can go ahead and start interacting with it. There is no connection.open. The minute you spark up the WebSocket, it'll kick off the process to go ahead and make the connection. So the first and most interesting one is actually sending a message out. So kind of pushing on the push side of things. And that one's a pretty non-trivial send method. And send really takes in anything. You can send it binary, you can send it text. Because it's going over TCP, it's really up to you. The WebSocket protocol and on both sides of the client and server, doesn't really do anything with the payload per se. So there's no need to be forced into JSON serialization. There's no need to learn how to do binary serialization. It's up to you as the developer to decide what that protocol is from one end to the other. And then once we're going to go ahead and we'll just stick the message in the window. This is just an internal method to render it on the screen. But as you can see on the client side, not a whole lot to send a message out to the server. On the reception side of things, again, as I mentioned, we wired up to the message event, and this time I just called it receive, and I'm getting an event back. And so to get the actual data out of it, all I need to do is parse the event data. And so in this case, I'm going to actually wire up the server to send JSON back because I want to send two variables. And so I'll unwrap the jQuery event, go grab the data element that comes back. Now, if you've used XML HTTP request, also known as AJAX, the data element will be very familiar to you. That's kind of how the payload gets transferred back and forth. So let's go ahead and append that message once that comes back. So here I'll just put data.name. And this is a dynamic object, so I'm not going to get any IntelliSense on it. Data.body, and I'll append that to the stack. So again, receiving data is a matter of just taking the data back and doing what you will with it. Closing off a connection couldn't be any simpler either. Connection.close. And largely, that's it. Now, it looks really, really simple from a client side, and it is. That's one of the things that they've been trying to do with WebSockets and server-sent events versus all of these hack methods that are out there around iframes, polling, and so on. Where things are probably not as nice and room for improvement is on the server side. But there's some reasons for that, and we'll actually talk a little bit about that as we build out the server end. So let's go ahead and take a look at the server side. We'll open up our chat handler, and we'll see a little bit about what's new in the world of IS8. So I'm just going to minimize this. So our chat handler is just a standard IHTTP handler. And in order to take advantage of this is all ASP.NET 4.5. So if you got 4.0 and below, I don't believe there's any plans to backport this because they've got a dependency in this case on IS8. So I'm going to get my request in, and the first thing I need to do is understand, is it a WebSocket request? And so what they've done in the runtime is they've handled the TCP handshake piece that happens out of the protocol and determined the fact that it is actually going ahead and trying to initiate through HTTP a WebSocket request. Once we've determined it is, then we can go ahead and take some action with that. So in this particular case, I'm going to go ahead and pull the name variable for my user out of the query string. And this is no different than any other HTTP request, because at this point, we haven't actually initiated the TCP conversation. We're simply ingesting that initial HTTP call. And so let's go ahead and stick that inside an object. And we'll go ahead and create that object here. All right, so, oops. And we'll just promote this to a public string name, get private set. All right, so we're going to go ahead and record the user. And once we've recorded who the user is, we're going to add it to a collection that we're going to maintain on the back end. Because once this handler completes, it has no record of the user connecting. So we're going to have to maintain the state of all the different connections in the raw WebSockets world. So let's do a static read-only. And this time we'll use a concurrent bag. And if you haven't explored this in .NET 4, it's basically a concurrent bag participant. This is basically a thread-safe collection or a thread-safe list, which is kind of neat. All right, so let's go ahead and stick our participants into our bag. And once we've got our connection recorded, let's go ahead and tell that, yep, we're good to go. Let's accept the WebSocket request. So at this point, this is where we initiate that TCP conversation. And this is also where things get a little bit messy depending on how comfortable you are with asynchronous programming. So the Microsoft.WebSockets library that's available on NuGet, which actually is the implementation of this, at this current release, relies solely on a series of tasks and async await calls to be able to make it happen. So what it wants to do is, at this point, hand off to a function that will sit there and sit in a loop, receiving data and responding accordingly. So we're going to actually do that on the participant object itself. We'll go ahead and create a receiver function that's able to take that handoff and be able to process it. Because after this, it closes out the HTTP request with its response saying, yep, you're good to go. Here's the TCP port. I'm off and running. So let's go to our receiver here, and we'll create our main loop, if you will. So at this point, we need to go ahead and create an async task, or sorry, an async method that returns a task to say, go ahead and receiver, go ahead and start working. So WebSocket context is the context object that they pass around. And so what we need to do at this point is effectively create a while loop that sits there and listens for data and responds accordingly. Because once the socket's open, there's no request-response mechanism inside the socket. It's just a continuous stream one way or another. So to do that, what we'll do is we'll sit there and listen for the pipeline, and we'll pull in chunks of data up until a point of a null return, or sorry, a carriage return being provided. So let's go ahead and pick up an array of byte and take in, let's say, 1024 for the sake of this demo. And we'll say result is await socket.receive. Oops. Sorry, forgot to grab the socket here. Var socket equals context.websocket as ASP.NET WebSocket. Socket.receiveAsync. So it's going to go out and wait for everything to come in, fill up the buffer. I'm not going to worry about cancellation, so I'm going to cancellation token.none. Oops. IntelliSense is trying to be too helpful. And once I get my result back, I'm going to go and do something with that. So the first thing I'm going to do is I'm going to go ahead and just double check the socket to make sure that it didn't disconnect as part of that process. So WebSocket state. And if it did, I'm just going to go ahead and notify everybody else that I've gone ahead and disconnected this. So I'll just come back to this, notify everyone else. Otherwise, I'll go ahead and take the message, and then in this case, I will just go ahead and unparse it because it's a bunch of bytes at the moment. And I will go ahead and send that message out to everybody else. So now I need to go ahead and wire up an event so that everybody else can go ahead and catch that message. Now, one of the things that you always need to be careful in any sort of network programming is, as much as there's an explicit disconnect routine, stuff happens on the network. You know, you lose Wi-Fi connection and so on. And so, you know, certainly be careful when you're in socket programming at this level if you ever need to get down to this level. And hopefully after you see SignalR, you'll appreciate the benefit. But make sure you catch and deal with the exceptions, knowing that occasionally that I was disconnected. That you you let everybody else know on the stack that the disconnection happened. And of course, like any good steward, if you're not going to really do anything with the exception, rethrow it out there so the app itself can handle accordingly. So there's a couple of events that happened here that we need to wire up. So we've got our main loop here that does our receive link, and it sits there in that while loop. And once I get that data in, It double checks it didn't close out, takes the message, and processes accordingly. It's a very generic loop. You can imagine interpreting that data stream for specific commands, deserializing it into, let's say, JSON, and doing something with that. This is a pretty standard kind of event message pump loop. So let's go ahead and create some events that are a little more interesting around sending and receiving messages. So let's first deal with the message received event. And so we need to be able to allow something greater to be able to do something with that message. So I'm just going to go ahead and publish an event. And I'll just say, this is for message received. So I'll just pass the message on and just let them know who it was that sent it by passing along myself. And I'll go ahead and create another one that I can tell everybody that I disconnected. Straightforward kind of event programming so far at this point. So let's go ahead and fire off those events down here. So I'm going to say if, and obviously you always want to check to see that somebody wired up to the event properly. If they didn't, you don't want to call the event, otherwise you get a null reference exception. And I'll just copy this down here as well. And more importantly, the more interesting event is letting everybody know that something happened. So if message received is not null, then let everybody know that a message was received. And so you're probably sitting there wondering, who subscribes to these events? How does that actually happen? Well, we can actually leverage our TCP handler here to actually go ahead and manage that process for us. So we'll just mark it as is reusable, so ASP.NET doesn't unnecessarily tear down the class all the time, because there's nothing in here that really holds on to state outside of our static, so we might as well just mark the class itself as reusable. But let's actually create something that will respond accordingly to those events and then send it out to all the other participants. So let's go ahead and start with void on participant on, I'll just keep it shorter so you don't watch me typing, on message received, and participant just to follow the same signature, participant, then string message. So once that message is received, let's go ahead and we'll wire that up into an anonymous object for JSON purposes. So we'll put in the participant's name, the actual message itself. And then what we'll do is we'll go ahead and send that data down the line. So what we'll do is we want to for each through each of the participants. Participant, I should have just said user. It's just easier. Okay, other users in participants. So we'll go through our collection and we'll say, of course, we don't want to send it to the person who sent the message, because that wouldn't make sense. We'd end up in a loop of we'd end up with the person receiving their own message back. Oh. Spotted a compiler error. And what we'll do is we'll simply go ahead and tell that other user to go ahead and send the message. But we haven't wired up any method at that participant level to be able to go ahead and send that message across. So let's go ahead and do a quick wire up on that particular event as well. So let's let's make sure I'm in the right scope here. Yep. So let's go ahead and public async task. And so you're going to notice this async task everywhere. This is becoming more and more of a common pattern across not only the ASP.NET side of things, but Web API and so on. Really trying to bring scalability by making things be a lot more parallel. So let's go ahead and actually convert this into JSON. We'll use the fabulous New Zealand-born JSON.NET to do that. But no woohoo for your countrymen. It's a great library. And then what we'll do is we'll go ahead and send the message. Now, before to be able to send the message, everything actually happens back on that socket connection that we were referring to earlier. Now, we didn't store that up here when we started off the loop here, so we do need to actually take a copy of that particular piece so that we can store that or use that elsewhere. So let's go ahead here and take a copy of that context here. So we can use that to go ahead and send out messages on that as well. And if you're thinking at this point, wow, this is kind of complex and painful, you're absolutely right. And we will talk in just a minute about how this gets a whole lot easier. So to send a message, we need that context. So we need to actually make sure that that got set. And we also need to make sure that the context socket is open. Because again, you can drop off at any time. So before you send a message, always check. And then because the whole thing is buffered through byte arrays, we're going to go ahead and stick our message back into a byte array. Bytes. Now that we have our byte array, we'll go ahead and tell the context WebSocket to go ahead and send asynchronously the buffer. And we'll tell it the message type. And you'll note that there is some distinction in the WebSocket protocol for at least text versus binary, but that's about as far as it goes. And we won't worry about cancellation. So now we've got the ability to send a message. We can go back up to our method here earlier, and you'll see it's wired up. So that's your basic loop for going ahead and wiring up the sending and receiving of data. And it involves quite a bit of network level awareness. Not only things like checking the state of the connection, you've got to be able to handle all the async stuff in the background. You know, it's a very, very complex model. And not only that, it comes with a bunch of challenges around it from an actual an actual protocol management level of all the nice things. So let me just, for kicks here, just make sure I'm all good. Because I want to show you as well the WebSocket handshake that happens here. Test 1. Test 2. Before I do this, I'm going to open that up. Make sure that guy got it. Good. So what I want to show you here is the actual handoff. And so what's happening here is this is the actual HTTP handoff. And after this, you're not going to see any other network trace of the WebSocket traffic. You'll have to open up something that's able to see TCP level packets for the exchange from here. What's happening here is it's issuing an HTTP request to the WS localhost chat ASAX. And it's doing a GET. It's passing in HTTP status code 101, which says I'm changing protocols. And the request header is saying, can you upgrade me? So it's saying connection upgrade. Here's my host. Here's my origin. Here's the various socket standards that I support in version 1.3. Here's some keys that I have so that if we want to do any sort of public-private key SSL style sharing, here's my public key. And in this case, I have a proprietary WebKit extension that I also support. And outside of that, please upgrade me. And so what comes back on the response is nothing. So he's going to basically get an HTTP response from the server saying, go ahead. And that's what actually upgrades him out to the port on the other side. So you don't see a whole lot of traffic from this point onwards, and that actually makes the protocol a little challenging to debug if you ever need to see the wire level stuff. So if you thought your days with Wireshark and all these other TCP level tracers is gone, well, it's back with WebSockets. But you know, that's all right. The performance gain that we get from that is quite a bit nicer. But more importantly, there's other things that you'll need to think about as you get into WebSockets, as you build real applications. Important things like keep alive messages, because firewalls like to shut down inactive TCP sessions. If you've ever worked in a corporate environment, especially a secure one, people can get quite aggressive about random TCP connections hanging out there. And so WebSockets itself doesn't have a mechanism for building effectively a keep alive or a ping message when there's no activity on the line. It also has no concept of queuing or timeouts. some of the things that you'll need as you start to build more active applications, if you will. In other words, on the TCP socket, it's one message at a time going down the stack. And so if you've got a user that's interacting very rapidly, you're going to have to think about building a queuing mechanism. And probably one of the more frustrating ones are things like error notification handling or just error handling in general. The protocol throws an error event, and the error event has a little bit of information, but not a whole lot. And so when you really dig into it, the protocol itself is really only a starting point in the current version of the spec, the 1.3 spec. This is the foundation that gets at least everybody on the same page as far as how we initiate communications and exchange data back and forth. So if you've purchased some of the commercial products out there that do the bidirectional communication, they're not gone yet. In fact, they go and build all this extra stuff on top to make it as rich as you need it to build real-world applications. And that's actually kind of where SignalR comes into play. Not only do they build on top some of that infrastructure, but they also help you patch it back for those older browsers. So in other words, if you've got the latest browser and you're running on IS-8, SignalR will naturally go ahead and choose WebSockets as its transport. If you're on IE7, IE8, and you don't have WebSocket support, it'll fall back to some of the hacks that I mentioned earlier. And it does this without you as the developer having to think about, what transport am I on? Am I going to have to react accordingly? They've also done a good look at the programming model. And one of the really interesting things about this as an open source project is they're actively taking feedback on this programming model. So where you saw the Microsoft.WebSockets implementation laden with async await calls and task calls, that API is going to largely be locked in the next little bit. And that's going to be it. And Microsoft's release cycles every 3 years before we see a major change. The nice thing about the open source side of things is we're going to see more concurrent updates to it with active feedback. Now, I have no doubt that the IIS team and the WebSockets teams inside the framework are going to actively listen. But I like the fact that in this day and age where things are still a little bit immature from a protocol perspective, we've got that rapid evolution of the open source side with this particular type of scenario. They've also done all the legwork if you need to support Windows, web, Silverlight, phone, no problem. And what I'll show you in a minute, I'm just going to actually hook up to SignalR with just a standard HTML page on Chrome. I'm not going to use any ASP.NET client-side stuff for magic. So as long as you've got a browser that's capable of JavaScript or a client out there that can talk WebSockets at the highest level or some of the other protocols, you actually don't even need SignalR on the client side. All it's going to do is save you some time to be able to do some of the wiring up pieces, because it's actually talking native protocol under the stack. So let's take a look at what SignalR's version of the chat stack looks like. And let me figure out where my is. All right. So we'll start back at our familiar page, the index page, and we'll take a peek at what's involved there in terms of wiring up the client side, and then we'll jump back to the server side. Unlike last time, I think you'll be pleasantly surprised that the server side actually is quite a bit more fluid from a programming interface perspective. We'll also go ahead and add in some extra fancy bells and whistles at the end to show you some of the bidirectional communication in action. So one of the first things that you're going to need to do is obviously open a connection, and that's no different than the WebSocket side. But what they've done on from a protocol or an API design perspective is they haven't associated the creation of the object with the opening of the connection. And to me, that feels a little more natural from an API perspective. I want to create a SQL connection, but I'm not ready to open it just yet. And so they've built in basically an extension on the jQuery framework to say, go ahead and get me this connection. In this case, it's called chat. And I'll show you where that chat connection comes after we build the server side. This in this case here, this is what is called my custom hub. And again, we'll come back to that when we explore the server side. So when I'm ready to open, that's totally cool. Go ahead and open. So what it's going to do is say connection.hub.start, and then it's going to give me a function to be able to do everything I need to do to initiate the connection to the server. In this case, I'm going to go ahead right away and just call a method on the server called join, and I'm going to pass in the name of the user. And again, you'll see the server side this in just a second, and it'll be like, oh, yeah, that makes sense. The next side I'll do is the send, and that one looks very much like you would expect inside WebSockets, except send message is actually a function I wrote. And again, we'll see that in about a moment. Close is a little bit different. Now here's where you're going to start to see a couple of the gaps, if you will, between all the different protocols. There is no, at this point in the current release cycle, an explicit close call on the wire. You actually have to send a command back to the server and let the server kill the connection. And so, and this mainly has to do with the fact that if you don't have WebSocket support, which has that nice .close, some of the other fallback methods that they have don't really have an explicit close option. For example, long-running HTTP requests, you'd actually have to somehow tell the browser to kill that request, and that's not totally doable from within the JavaScript API. So at this point, I'm just going to go ahead with my current hack for close and refresh the page. Now, what we haven't dealt with is the receive method. And receive, again, works a little bit different. I'm not going to wire up an event straight on the chat. I'm actually going to extend that object itself. And again, if this is all feels kind of weird and stuff, come on Friday and we'll talk a little bit about how JavaScript and prototype inheritance works. In this case, I'm going to create a function or a method call on the server called broadcast, and it's going to give me a method with a function. And it's going to very much work like the receive method did before. I'm going to go ahead and get my data back, and I'll go ahead and parse it out. And I'll append it to the .name data.body. So that's kind of your basic bits of chat. And you can see it's really not all that different from WebSockets. You know, the API is pretty reasonable. But a lot of this actually happens to be generated, and all the magic happens to be generated through this call here to SignalR.hubs. And to really understand what's going on there, we need to go explore the server side and build that piece out. So let's go ahead and do that. Save first. And let's go ahead and add a class called ChatHub. Now, SignalR supports two concepts of connectivity. One is called hub, where it manages essentially the hub being a hub and spoke type system. The hub is the center, the spokes being all the connections, or lower level persistent connection. I'm not going to get into the persistent connection in any detail. I want to kind of get you up and running as quickly as possible. So we're going to start with the hub side of things. So to make that hub work, we're going to go ahead and inherit from the hub class. And we'll go ahead and do our code complete, and we'll give our hub a name. Now this is the name that the client knows it as, so I can call the class whatever I need to. Chat hub, two-way communication, fancy hub class protocol. But on the client side, I can keep it nice and simple. So it just allows me to drop all my server-side nomenclature and have a nicer experience on the client side. So to join the chat, that's really easy. We need to create that join method that we saw earlier. And that took in a name. And we'll go ahead and take our participant. So I need that participant collection back again. So this time I'm going to use something a little bit different, and I'm going to use a concurrent dictionary. And static read-only concurrent dictionary. And I'll tell you about that in just a second as to why I'm going to, oops, wrong hotkey. There we go. Equals new. Oh, it's still struggling. I haven't created the participant object yet. Yeah, let's do the right thing. We'll call it user. So this dictionary is going to hold my collection of users, but it's going to be keyed by a special connection ID. Now, my participant object itself is nothing more than really a data holder. So let's do a public class, or sorry, my user class, because we decided to go with a simpler name. And so I'll just put in a string ID, get set public string name, get set public string connection type. We'll come back to that connection type in but a moment. Make sure that's all happy, good. All right, so now how do we join our conversation here? So let's say var user equals, oh, I got a name for that, equals users dot context dot connection ID, and if I don't have one, create a new user with the ID equal to context dot connection ID. So what's happened here? So when the user hits the hub for the first time, it creates a connection ID to record and track that conversation. At the moment, it's just a string value, and by default out of the box, it's just creating random GUIDs. You can override that behavior if you want to look up, for example, the ID based on the user's cookie, auth cookie, or based on any other value. But out of the box, it just creates a random or a new GUID for every connection that makes it to the server. And that just kind of helps us get started here. What I like about that approach is it doesn't force you to have to code that sort of connection management aspect if you don't really care too much about it. You can just use it and continue on. So let's go ahead and set the user's name. And then we're going to go ahead and take note of the connection type. And again, we'll come back to this at the very end. So whether they came across with WebSockets, forever frames, and so on. So let's go ahead and add or update. And we want user.id, user, and this is just a little bit of noise in this particular collection. I really just want to add the user. This allows me in an update case to be able to selectively change things. I'm just going to say overwrite it for now. And at that point, I've gone ahead and I've joined the collection. The other piece I need is to send a message. So this is when the user wants to broadcast back out to everybody else. So let's go ahead and, because we're sending it back in JSON, or we're sending it out in JSON, we'll go ahead and create an anonymous object here with the name is equal to the user's context.connection ID. So the connection ID of the person who made the call to this, and we'll go ahead and get their name. And then body is equal to message. So it just allows us to go ahead and get a string with that object on, and then we'll for each through the var other user in users where the is not equal to context.connection ID. And oops. And then what we'll say is clients with the other user.key broadcast data. Now, a little bit of magic here that just went on, but what I want you to note is we've effectively built out the same chat application with a whole lot less code. You haven't seen a single async await call. You haven't seen a single task. You don't need to know about any of that stuff to start using it. This is kind of the beauty of what they've done with the SignalR model is they've built an API that's instantly usable. But let's talk a little bit about the magic, because there is magic going on here. So first off, when the connection comes in and initially makes a call to any one of the methods here, it's going to establish a context. And so that context object has a couple of key properties on it. First being the connection ID. So SignalR is going to manage the different connections for you, and it's going to assign a unique connection ID to each one. That's your unique identifier to know who called. But you'll note that by calling the method here, I'm not calling the method as the user. You have to go and assert which connection it is that's there, and this is the way to do it. It's also going to expose out standard HTTP things like headers, query strings, request cookies, server variables, or heck, even if you're using ASP.NET in forms auth and you set a user on the thread current principal, it'll go ahead and expose that as well. So it cleans up the API and exposes all the things you need to know to establish who's the user, how are they making the call, and did they pass any sort of query string or any other cookies along with that call. And so we use that to kind of go ahead and add the user when they first call join to our internal collection so we know who's all out there in the world. We then noted a couple of properties about the user and added them to our collection. On the send side, we leverage that collection we used to go ahead and get the user's name. And then we created an object that we could send out to all the other users. Now, there's actually no method on the user object to send the message. All that happens through this collection called clients. And if you look at clients, clients is actually a dynamic object. You hit IntelliSense on it, there's not going to give you much. Because what happens is any method called on clients translates into a JavaScript equivalent and is called on the client side. So if I call client side foo bar, it's going to go ahead and create a JavaScript equivalent of foo on the client side and send the string bar down the line. Now, if I don't specify any specific client in the collection here, this by default is going to go to everybody. And in this particular case, when I'm sending a message in a chat scenario, I don't want to rebroadcast the message the user just sent back to the user itself. So I went and said, I want you to cycle through every user out there and only send it to a specific user, and as long as that user is not the actual one that sent it. So if I do want to actually send it back to the user for whatever reason, I can simply just bypass that out, say clients.broadcast data, and that will send it to everybody. When I compile this and access it from the client side, you'll see in just a second here where the magic really comes together in terms of the JavaScript side and all these dynamic objects. Let's go ahead and set this as the startup project. So we're going to go ahead and take a look at the sources, and in particular, the call to SignalR/hubs. This is a magic URL. It can be moved to any URL name that you want, but out of the gate, you call /SignalR/hubs. And this is the dynamic JavaScript that you're going to get back from the SignalR environment that wires in all that functionality on the client side. So let's go find our hub here. There we go. So there's our hub named chat. And you can see I've got my two methods that I created on the server side called join and send message. This is what allows the client side to actually communicate with the server side. So they're generating this at runtime. You don't have to code this from a JavaScript perspective. You just create your server-side method, and it'll be available on the client side thanks to the auto-generation, if you will, of the hub itself. So let's go ahead and see this in action. So I'll go ahead into test 1. If all worked out, we've got that exact same effect with a whole lot less code. So I'll wire in one quick little extra in this. We'll take some Q&A. I've got some prizes to give away. And what I like to do is make this just a touch more interactive. So the one thing I like to know, I want to show is to show it actually doing some interactive back and forth, if you will, where the user's not necessarily having to interact with the page, just to give you that true, kind of real-time look and feel. So I'm going to put a graph on the page here, a pie chart using Kendo UI from Telerik that shows you all the different users connected and how they're connected. So the graph itself is a little less relevant, but more I want to show you the actual method that updates it here. So I'm going to say connection.refresh stats. So this is the callback that the server is going to make every time somebody connects or disconnects to go ahead and refresh the graph. And in this case, I'm going to take the data, I'm going to go ahead and parse it out of the message, and I'm going to go ahead and get my chart. Oops. User statistics dot data Kendo chart. Go get me the chart object sitting on that. I want you to don't make this fancy. Oops, that should be options. So turn off the animations, but then just simply go to the data source and set the data to the data I got from the other side. So that's just going to update the data source on the chart with the latest information. Let's go back to our chat hub and add in all of the necessary functionality to make that actually work. So the first thing we'll need to do is we'll need a refresh stats call. And so in this particular case, we're actually going to go ahead and first, actually, let's wire up the connection points when that all happens. So the stats, when the users actually get updated, we want to update on both when they connect and disconnect. So we're going to add the I connected, I disconnect. Oops, if I spell it right, disconnect interfaces. And this basically allows you to wire into when a client actually connects and disconnects. Now, as I mentioned, depending on the method that you're using, disconnection may not always be reliable. For example, if you're in a long-running HTTP request, disconnect only happens when the server notices that the HTTP connection has actually finally dropped. But let's go ahead and I'm going to go ahead and pull out some information out of it, and I'm just going to go ahead and paste this in for the sake of time. And then we'll go ahead and refresh the stats here, and I'll come back to that one in just a minute. The other one is reconnect. We'll go ahead and do the exact same call here. So when the user reconnects, we'll add them to the collection. And I'll go ahead and refresh the stats. And then in the disconnect mode, I need to get rid of them from that particular collection. So this one, we actually need to respect the concurrent piece. So there's actually no straight remove, it's try remove. In this case, I'm going to say go try and remove the person with the current connection ID and drop them into the user bucket, even though I'll just leave that variable and do nothing. So this is where you'll see a little bit of the async piece bleed through, if you will. And again, you only need to get experience or get tuned into this if you actually want to understand some of the under the covers piece. But let's go ahead and create a refresh stats option. So this is going to do all the legwork. And this is pretty easy. Just go ahead and get the users, group them by the value.connection type, and then select the transport is equal to, just get me the first entry on the grouping, .connection type, and then the count is equal to the number of elements in the collection. So just a little bit of a standard link get by, group by call. Not quite as nice as doing it in T-SQL, but nonetheless does the job. And then let's go ahead and serialize that. Stats. And let's go ahead and then send that down to everybody. Now, because the methods I call are looking for an async task, I will go ahead and pass them back an async task, which is really any call on that client's. You don't have to, when we were calling it before, we didn't really care about returning the value because we weren't doing anything else with it. This is just going to pass the control back over to the rest of the stack to continue to finish processing. And why is that complaining? Missing. Oh, yeah, perfect. All right, so now that I've got my stats back, I can do some interesting stuff here. Let's go ahead and rebuild. So user one, I'll sign in. I'll just kind of show you. Oh, I've already got 3 users in the collection here because I have my 2 other windows open. Let me go ahead and drag in our good friend IE. Oops. Where'd you go, IE? There we go. That's trying to get out to the network. It won't succeed. All right, let's paste in our collection here. And I'll go ahead and join, test 4. And so you'll see it just immediately updated to 4. Let's go ahead and change my browser mode. Let's go back to 9, which didn't support sockets. And you should see 3, because I disconnected. But let me go ahead and sign in here. And bang, there's Forever Frame. So there's it falling back to the older modes. And it's got a couple of other tricks up its sleeve, but for the sake of time, those are the 2 protocols just to show you how older browsers would react. And IE8 and so on would fall back to Forever Frame as well. So For those of you that understand how TCP works, and it's something you'll get to know as you start to do these sorts of large asynchronous programming, you'll know that there's only so many TCP socket or connections that can be open to any one server at a time. So how do you scale up to handle something like Twitter or the internet? The reality is from a programming model perspective, the current thinking is that you share a common backplane, such as a message bus or Redis or Azure, and Velocity, which is now the App Fabric caching, and you're able to exchange messages between the various hubs. So you can think of every server will have a max number of connections it can handle, and from there you can scale out to other servers as well, and then have a common backplane. Right now, out of the box, Azure Service Bus and Redis are the two ones supported. For those who don't know Redis, there is a Windows port from the MS OpenTech guys that make it work quite nicely on Windows. But if you are getting up to this sort of massive scale, and I'm talking tens of thousands of users, there's a couple of performance tuning tips that you'll want to do on the GitHub wiki for SignalR. If you're just doing this inside a corporate firewall and you figure there's a couple hundred people connecting at a time, these performance tuning tips won't make much of a difference to you. But if you are doing the public side of things, you'll definitely want the performance tuning tips. One thing to be aware of, and this is more not just web sockets, this is everything happening around communication on the server, is the cross-domain support. If you've encountered this already with scripts coming from other domains and browsers saying, hang on, I can't accept that, it applies equally as well with WebSockets and all these other protocols. The nice thing is they're solving the security lockdown by using the same sort of mechanisms to open it up. I don't have a whole lot of time to get into cross-origin resource sharing, but if you just Google cores, there's a number of sites out there that talk about this in depth. This is basically to stop people from injecting scripts on your page from other sites. The browser manufacturers locked it all down, and they finally have started to open up to be able to support that scenario again with a little more security. So with that, I'm going to close down with a couple of links, but I've got some questions for you in the last couple of minutes here to win some prizes. I've got an ArcTouch mouse, I've got an exam voucher, I've got a couple of shirts from Telerik, and if you've got a business card on you, I'm happy to throw in a Kendo license as well, because I think it's a fantastic control suite, regardless of what platform you're on. So I'll start with the first one that can raise their hand and tell me, what protocol does WebSockets use? TCP, awesome. You want to come up and grab a prize? I'll go with the next one. What version of IIS do you need? Right there? 8? Yep. Come on up and grab a prize. Grab one, anyone? You want the Kendo?
Yeah.
Okay, cool. Awesome. Yeah, I'll fire you an email and you're good to go. All right. And what was the name of the push version of the HTML5 technology? The push, not the WebSockets. There's one other one. Yep, correct. All right. We got 2 more prizes up here. Sorry, these go together. That's a USB key and exam voucher.
All right.
Yeah, cool. And what is one of the names of the authors of SignalR? Hint, it's on the slides, yes. Sorry? Yep, excellent. Come on up. And for the very last T-shirt prize, what is the name of the web stack which SignalR is built on? This should be an easy one. What's the server runtime SignalR is built on? Right at the back. Excellent. Thank you very much. Appreciate you coming out, folks, and go engage the real-time web.